Welcome back, dear students, and now we are going to use some operations on the set. So we are going to use some operations on our set. Well, if you have studied set theory in your junior high school or high school, you surely know about the operation of intersection, union, and all those kind of things. We are going to use that and apply that right here, right now. So let's just do that. And if even you have not done that, don't worry, we are going to learn it right here. So to apply the operations, first we need to create the set first of all. So let's create a set. Let's create a set with the simple numbers 1, 2, and 3. And now let's name it set 1 so that we do not get confused with that. Okay, let's write set 2 is equals to curly braces, and we are going to put let's say 3, 8, 2, 9. Okay. So we have created two sets, and now we're going to apply the intersection. So for the intersection, I'm just going to write intersection itself. So intersection is equals to set 1 dot intersection that we have applied, okay, with set 2. Okay, now let's just print intersection. Let's try to hit enter. As you can see, the result is 2, 3, because that's the only common thing, and intersection means the common part in set 1 and set 2, which is just 2 and the 3. So we have just got 2 and 3. This is how we use the intersection. It's so simple. Just write the intersection, right? Set 1 dot intersection of set 2. So this is the way we are going to write it. And even if I change the format here, like I write set 2 and set 1 here, in the intersection case, you are going to get the very same result. Let me show you here. See, we have got the same results because intersection means the common point. So common point from A to B or B to A is pretty much the same thing. Okay, with all that, let's apply the another one, which is union. Union is set 1 dot union bracket set 2, and now just print union. Union just basically is the totality, and let's see what we are having with the union. So as you can see, 1, 2, 3, 8, and 9. So it came in the readily sequence of the number, and surely the sequence is going to change as many as times you want. But here we are going to get 1, 2, 3, 8, and 9. So this is the totality of number, and the repetition is not allowed in the set theory. That is one important thing that you need to remember all the time, that set theory do not allow any kind of repetition. I'll show you that in the later part of it. Okay, let's just create difference. Well, difference is very simple to understand. Difference is just a difference, means you are just eliminating something from one thing, like from the set 2 dot difference. Okay, difference bracket set 1 print difference. And always remember, we are not using any apostrophes when we writing print, because we want Python to understand it, and we just do not want to simply just going to use it as a text and show it up. So maybe there's some spelling mistake at that. Let me see. Okay, here it is. Here is the spelling mistake that we are having. E-R-E-N-C-E. Okay, now I think it's fine. Yeah, it's fine now. So it's just 8 and 9. So we have just eliminated that, and in the difference, let me show you something special. If I change the set the way we have it in it from 1 to 2, we are going to get just 1, because 2 has eliminated from the set. So we are eliminating and not just simply subtracting. This is how the set theory works. Okay, let's have the other one, which is symmetric. So in the class, I have told you that I'm going to teach you the symmetric one in the session of practical itself. So we are going to learn that right now. But I still think that you have got the idea of that, how it's going to work, because it's just not very much different from the things, right? And sometimes what you think actually happens up. Now we need to print it up. So print symmetric difference. You can see how much time it saves when it pops up again and again. So let's hit run. and 189. So this is the symmetric difference, means 1 is present in set 1 but not in set 2, 8 is present in set 2 but not in set 1, and 9 is present in set 2 and not in the set 1. So this is the symmetric difference. Well, we can just change it and let's see that what's going to happen here. 2 with the 1 and we are good to go. The result is pretty much the same because just like the intersection case, the symmetric difference we are finding, not the difference. Remember, difference shows a different thing, but the symmetric difference is going to differentiate the elements, which is in first element but not in the second one. So this kind of differentiating element, you can imagine that in the advanced level, when you are trying to program something, you want someone to access a particular part and you want not to get access, or someone not to get access of that particular things. So you can check it out here by the set theory, or the means of the set theory, that first, what are the difference between the user and the creator itself. So this is how you can create that matrix in your work. Okay, so that's it for the set theory. I hope you have enjoyed the set theory a lot, and just like me, keep on practicing, keep on learning, and keep on growing. Sayonara.